Hello everyone, my name is Emma and as mentioned I'm going to be speaking to you all about fin whale songs. I'm very new into the field, so this is just 4 months of me seeing what I can get from a vast set of data under the supervision of William Ferneman and Fani Shabangu, with thanks to Ivana as well. Cool. As Aaron mentioned, our talk overlaps quite a bit. So whales are very important. They are often ecosystem engineers. They contribute to biodiversity. They contribute to nutrient cycling, both through the whale pump and through whale fall. They contribute to carbon sequestration, also through whale fall. They are keystone species, an excellent sentinel species, and they create strong oceanic links, vertically, benthopelagically, as well as polar equatorially. In the past, the main threat was whaling, but since the moratorium, the present threats include bycatch, vessel strikes, climate change, habitat degradation, entanglement, food scarcity, pollution, and noise pollution. That's a lot. As Aaron mentioned, we don't know exactly what whales call for, but the leading theories are they transmit information, they coordinate complex behaviors. Then songs evolve within and between populations through selective and non-selective evolutionary processes, but the change in song is often limited to the singer's morphological and neurological restrictions. Fin whales are the second largest living species on Earth. They are the fastest whales in the ocean. They often form small groups, but can aggregate in large numbers in areas of high prey density. They are cosmopolitan, and they have seasonal movements that are likely timed to breeding, feeding cycles, where they go to higher latitudes during summer months. They are long-lived with low reproductive rates, and they play a vital role in the Benguela and Southern Ocean ecosystems. Our population that we have here on the west coast are the eastern Antarctic fin whales. So fin whale songs consist of 20 hertz pulses that are often accompanied by 99 hertz overtones. Sometimes they have a backbeat. This is specifically obvious in the Portugal population. And then they have 40 hertz feeding calls. These calls are regionally distinct, so we can tell which populations they are by looking at their calls, specifically the high frequency notes. And they have internote intervals, which is the space in between the pulses, and the variation in that is also indicative of different populations. So there's a vast set of data that Fani gave me access to, for which I'm very grateful, collected off the west coast of South Africa over 3 years, from 2014 to 2016. These are the locations of the acoustic hydrophones. There's a lot about them. I will not go through that. It's a very big graph with lots of words on it. Hello? Okay. So the visualizations were done through RavenPro, looking at presence and absence, and then specifically looking at song characteristics, minimum frequency, maximum frequency, peak frequency, duration, and then I classified the calls by quality. Afterwards, the idea was to go back into the data and look for internote intervals, but I did not have time for that. So all analyses were done in R, and I went retroactively and coded for internote intervals, which was a hassle, and it made me cry a lot. The analysis was done on good data, which I'll explain in a minute, and I did an ANOVA and a Tucky HSD post-hoc test to see the differences. So the data are quite messy a lot of the time, and thus we decided to go through and look for different quality calls and see how that influenced the actual results. At the top, you'll see what I classified as low quality calls, which were generally in noisier environments. The calls weren't that clear. Generally, fin whales have a straight bar if it's very clear. You can also see like two distinct circles connected to each other around the 20 hertz frequency, and then sometimes they will be accompanied by those 99 hertz pulses. So the top layer is low quality, the middle layer is medium quality, and the bottom layer is high quality. As you can see over here as well, often they'll have two individuals calling next to each other. In that instance, I chose to select the clearer call, and not do the second call or the first call depending on where the clearer call was, as that would influence the internote interval. The data. There were no feeding calls on the West Coast, but I was able to get 23,108 observations of 20 hertz calls and 99 hertz frequency pulses, all broken up into low, medium, and high qualities. As you can see, the high qualities only make up 5% of the data. So I went through, also, most of the calls happened in winter, some of the calls happened in autumn, and even fewer in spring, but there was a notable absence in summer. Once I had these calls broken up into low, medium, and high quality, I checked how the quality influenced the data, and it did actually influence the data quite a bit, specifically with duration between high quality and the other two, and peak frequency between high quality and the other two of the 20 hertz pulses. The 99 hertz pulses weren't influenced that much. I took the data sets, made like a all data set, a good data set, and a best data set, where the best data set was only high frequency, the good data set was high and medium high frequency, high quality. The good data set was high and medium quality, and the all data set was all of the data. And I chose the good quality one because it represented all 3 years. The high quality, we didn't find any high quality calls in 2014. But yeah, so it represented all 3 years, and the differences, as you can see over here, they're pretty much on par with each other, with the good and the best are pretty close. After that, we noticed that there is a bit of a shift that happens both in specifically, in duration of the 99 hertz pulses, and that there's a lot of variation in the 20 hertz pulses. Yeah. Sorry. The thing to note was this, the internote intervals. There seems to be a trend beginning, but the big take home from this was that even though I had 23,000 and something observations, 3 years of data is not enough to know how fin whale song evolves, as they evolve very, very slowly, at least along our coast. So the key findings were that there were no feeding calls, which suggests there's a strong seasonal presence during breeding months, the predominance in winter and noticeable absence in summer could likely identify the West Coast as a possible migratory corridor. There were no backbeats. Call quality has a strong influence on the data, and the described calls often a basis for comparison to other fin whale populations. Yeah, as I mentioned, our preliminary results suggest that there is a growing trend in INIs over the 3 years, but it is not long enough to make any conclusive decisions on. And then the shifts we do see could be due to random variation or cultural drift, as mentioned by Erin, social learning, adaptation to increasing noise, and increased competition post-whaling. That's a new theory that I stumbled upon a week ago. That's very weird. Anyways, thank you guys.
All right, thank you so much, Emma. That was interesting. Well done on doing such analysis. 23,000.
Yeah.
Of course, that's a lot. I can imagine that took you a lot of time to do. So it's good to see these results and seeing this project come together. Jan, I'll open the floor for questions, and I'll remind the people online, you've been very quiet, so maybe please post some questions as well.
I have a question and a comment.
Okay.
On slide 9, you showed a good quality with 2 downsweeps very close to each other, and you said they were 2 animals. I would urge you to look at the fact that when you see that, there's modal dispersion in fin whale calls, that it's probably a different arrival of the same call, which you can actually get ranging distance from if you know your water, your wave guide in the propagation. So be careful in saying that those are 2 animals when
Okay.
I believe that what you're seeing there is the modal dispersion of different arrivals of the signal bouncing off of the surface or the bottom.
Cool, thanks.
And second, have you thought about using SNR as a parameter to quantify your quality of calls as opposed to having it be more subjective?
SNR?
signal-to-noise
Thank
ratio.
you.
Yeah, sorry.
I have done science, I promise.
Signal-to-noise ratio. That might help you quantify your categories a little bit better, which would, I think, lend itself to more technical, statistical, and robustness tests.
Okay, cool. I haven't thought about that. I haven't looked into that, but I'd love to. It sounds like a very good idea. I'll come chat to you afterwards. Thanks.
Fight you for it. Hi, Emma. Thanks. It's quite a big amount of work you've done there. Did you look at frequency parameters at all? I know in blue whales and some other fin whales, there's been shifts in frequency.
So not in blue whales, unfortunately. I specifically focused on fin whales. We will be hearing a talk later by Gauri, who's doing blue whales, and Ivana's doing 8 or 10 something species, 8 species around Marion Island. So I focus specifically on on fin whales. Yeah.
We still have time for more questions. Yeah. Thanks, Jan, for that suggestion. I think you're talking about doublets and triplets, which are sometimes recorded for fin whales. So we'll look into that. And yeah, this is a first project for Emma to look at. So we didn't look at the signal-to-noise ratio. That's something we can look into in the future. Yeah. Other questions or comments for?
Sorry, I just have a comment. Like, it would be I think it would be very cool because you could possibly see a difference between having 2 individuals and the refracting effect, because often when you get 2 pulses that close to each other, you'll see that they're like shaped differently and the hertz are like in different peaks as well. So it would be, yeah. Okay, cool. Anyways, I'll come chat to you after. Yeah. Thanks.